Today's class is on software-defined reality, and this is our concept of how we build scientifically accurate and realistic synthetic data. I am your host, Jose Lacal. Let's start. The need for synthetic data, this comes from the specific requirement that many businesses and organizations have to test and validate early and often and without any restrictions. There are several ways that this requirement manifests itself. All systems and processes need to be fully tested before going into production. In some industries, specifically medical devices and pharma, there are strict regulations for providing evidence of how you conducted that testing and validation. Synthetic data can be used to represent the customers, the processes, and the products and the services that your organization delivers, as well as the market conditions that you are going to face out there. The problem with using real data is that it's not easily available for testing purposes. Number one, there are privacy regulations, as we all know, GDPR in the EU, HIPAA in the US. There are also security issues. For example, you don't want your customers' credit card data to be used for testing purposes. The other factor, a more subtle one, is that in many cases internal data has limitations on reuse, meaning you collected the information from customers for one purpose, it may not be easy to use that data for a different purpose. And in many cases, real data does not address corner cases. This refers to out of the norm or out of the expected values. For example, in the healthcare space, you may have a male individual that's diagnosed with being pregnant. So that's what a corner case refers to. And also, real data is expensive to acquire, and then you need to safeguard that data. Therefore, what we need to find a way to build fake but realistic synthetic data. Data cannot be totally random or nonsense data. It needs to be useful for testing purposes, obviously. And synthetic data has to be representative of what we call the patterns of reality. So there has to be some correlation between the synthetic data and reality. Then the way we build synthetic data is realistic and yet scientifically accurate. So first of all, we use open data to understand reality. What does that mean? Open data is data available from the US government and other governments in different countries. Two specific examples of open data. In the US, you have data from the FDA, such as the approved drugs and medical devices. You have the list of Medicare providers, that's called the NPI. And you also have, at the state level, the list of all licensed professionals. In the EU, you have a similar list of approved drugs and devices, and you also have terrain and transportation digital maps. All of these are examples of open data, again, freely available from government sources. From our perspective, open data represents reality, because most industries and professions require some sort of government regulatory or license approval. These government agencies disclose most of the non-personal information they collect. Again, in the case of the US, you have the FDA that regulates the pharma and medical devices space. That is the reality of that space. So through the FDA, you can get a pretty good view of what is happening in those markets. Open data is updated often, driven by the underlying regulatory process. Obviously, if you have a state-level license as a plumber, for example, you need to renew that license on a regular basis. We take that open data and it becomes the baseline for our synthetic data. Open data is free to use, there are no constraints, it's very fresh and it's highly accurate by design. Again, if you're a plumber, you do want the state to keep you in good standing with them. And this open data is available for every industry and every country. So then the next step is we take that open data and we extract what we call patterns of reality. And think of reality as a series of layers built using open data. At the bottom, the first layer is nature, what's there. rivers and mountains. The second layer is the transportation infrastructure. Then we have the urban infrastructure and dwellings. By looking at dwellings, we know what is where. Then we have the entities, people, organizations. This tells us who is where. Then we have the activity, who does what. And finally, we have knowledge, why things happen. And think of this as the layers in a cake. At the bottom, you have nature, and then transportation, and all the other layers. All of these layers come from analyzing the open data that we referred to earlier. So the first layer is looking at nature. What is out there that's not man-made? For this, we use our own geographic information system to identify rivers, mountains, digital elevation models, jungles, oceans. That's layer one. What's in nature? Layer two is human elements, transportation. Again, using our GIS platform, we can map roads, highways, bridges, and traffic models, meaning what is the flow through highways and roads and bridges, so that we understand the transportation networks out there. The third layer is the urban layer. And here we look at towns, cities, streets, and also power lines, sewer lines, what's on the ground built by humans that creates this livable infrastructure in the urban environment. The next layer are the dwellings, the buildings, but also the height and the square footage. So we can estimate how many people live in this house based on the size and the height, and also zoning rules. What is allowed in this area? Is this urban? Is this agricultural? Is this forest? Is this a national park, for example? This layer tells us what is where. The next layer tells us what are the entities that exist at the municipal, state, federal, and international level. Basically, who is where. For example, and this is from the US, the National Institute of Health provides a summary of all of the grants that they have issued in the last 20-30 years. At the state level, in the state of Florida, in the US, you can get a list of all the corporations registered in the state of Florida. Again, this layer, who is where. The next layer is going to tell us on layer 6, the activity. Who does what? Looking at open data by profession, by industry, and by regulator. And the first one, upper right, is CMS, Center for Medicare and Medicaid Services, and the list of all of the Medicare providers in the US. And then the one at the bottom is from the EPA, the Environmental Protection Agency, that provides us with a list of all of the facilities that need to register with the EPA because they emit substances or they handle some sort of elements or substances that need to be reported. And then in the final layer, what we see is we have the ability to determine knowledge by profession, by industry, such as why things happen. For example, in the case of the FDA, what drugs were approved, and also in more granular detail, the adverse events reported against medical devices. So think of this layer as the summary of how people and entities and facilities and processes came together to generate knowledge, and most products and services are the result of that knowledge compilation. So then what we do with all of these layers is we build and test alternative realities with this synthetic data. What that means is that our synthetic data is scientifically accurate and realistic. It's available across industries for both the EU and the US at scale and on very short notice. And the key element here to keep in mind is that our synthetic data is based on those patterns of reality that we covered earlier. And there is a close correlation to the real data, yet there is no connection to real individuals or events. That's what we call realistic and scientifically accurate synthetic data. Therefore, you can use our synthetic data safely. There are no copyright issues, no privacy issues. Securely, you can run this inside your own facilities. Privately, nobody needs to know what you use the data for, or even that you are using our data. Quickly, we can deliver data in a matter of days based on your specs. Inexpensively, our synthetic data is significantly more inexpensive than other data, such as anonymized data. And repeatedly, you can take these data sets, these cohorts of people, and you can rerun them as many times as you want. And this gives you consistency, because the same patterns of reality present themselves across all the data sets that we deliver. At scale, what we're building here is what we call reality composers, where through our synthetic data, we allow you to build end-to-end alternative scenarios, so you can build, run, evaluate, adjust, and rerun those scenarios. Let me cover that. So what are those scenarios? That's what we call software-defined reality, where you take our high-fidelity, realistic synthetic data, and you extrapolate that data to create alternative universes with fully synthetic data that fit your specific processes and procedures. Think of this as your existing data is reality. There's a single layer of reality. But underneath that single layer of reality, think of the caves and tunnels and underground bridges and underground parking garages that we can build with synthetic data. Something like this. Your real data is on top. We don't touch that. That's untouchable. But underneath, we can run all kinds of simulations and scenarios using our synthetic data that closely matches your reality. So there's one surface, but there are many thousands of levels underneath the surface that we can build for you. The next step are looking at what are the most common use cases for this synthetic data. And when you look at realistic and accurate synthetic data, we can build synthetic people, such as synthetic patients, synthetic consumers. We can build synthetic places. We can build you an entire city or country or even a planet-size synthetic universe, synthetic planet that meets the patterns of the reality of the jungles and the rivers and the mountains of Earth, for example. We can also build synthetic organizations, companies, synthetic accountants, synthetic medical device companies. Synthetic buildings, same thing. We build a whole new country and we put synthetic buildings in that synthetic country, as well as products. And I want to emphasize two elements that may not be so obvious. We can build synthetic services and synthetic money flows. Let me explain. Synthetic service, for example, the reality is that in the US, the FDA publishes a list of all the adverse events caused by pharmaceutical products, and that's called ERS. We can generate synthetic adverse events as well. Using the ERS database as the baseline, the reality, we extract patterns and then we build synthetic adverse events. The next example is money flows. And you may wonder, what do we mean by synthetic money flows? In the US, the reality is that Medicare provides a huge database of all the reimbursements that they have made to Medicare providers, such as physicians, for example. We have that data already processed, and we can build a synthetic flow of money in the Medicare space in the US today, using the patterns of what Medicare has reimbursed for the last 5 or 6 years that are available, and then we extrapolate from that. Okay, think about the possibilities. And the other thing that is important to highlight is that we go beyond this AI fad out there. Everybody's an AI company these days. In our case, reality is our model. We simulate any type of real data. If there's an open database that we can use, we go from there. We never have to connect to the client's data as a baseline. So again, your data is privately and securely kept by you. Our data is infinitely scalable because we just extrapolate from those patterns. It's available on short notice without any usage restrictions. And in our case, you can choose fast, simple, or inexpensive. We give you all three. Finally, a word about our company. We are domain experts in terms of data, and we're passionate about data and software. We have over 20 years experience handling open data and over 15 years of health IT work. We have a deep focus on life sciences and a personal passion for life sciences as well. We have a dedicated in-house team of database and software engineers. We have large-scale system expertise, and we can build custom file formats to fit any client's needs. From a technology perspective, we never touch the client's real data. We have an extensible data acquisition and integration platform. We can take any data source that's out there from the open data space that matches your real data, and then we can build synthetic data from that baseline. We also enrich open data, specifically in the healthcare space. We do a lot of name harmonization and name mapping. We also cross-reference open data. So not only do we take mailing addresses, for example, we can geocode them. We can insert definitions of the fields instead of just codes. And finally, we use open data to build a unified view across agencies, across countries, and across industries, all in one place. So thank you for listening, and if you have any questions, please reach out to us. Thank you.